Yes, the National Electrical Code allows you to tap your 2/0 grounding electrode conductor that is coming from the cold water pipe to the main service panel. National Electrical Code Section 250.64e addresses the specifics of this practice. According to this section, the grounding electrode conductor is permitted to be tapped for the purpose of grounding other equipment or systems. However, it is crucial to adhere to certain requirements to ensure safety and code compliance. Firstly, the tap must be made with a listed grounding connector or lug. This ensures a secure and reliable electrical connection. A listed grounding connector or lug has been tested and certified by a recognized testing laboratory to meet specific safety standards. Secondly, the tap must be made in a manner that does not reduce the effective grounding path of the grounding electrode conductor. The grounding path must maintain its integrity to effectively carry fault current back to the source. Avoid making the tap in a way that could compromise the conductivity or physical strength of the grounding electrode conductor. Thirdly, the tap must be protected from physical damage. Physical damage can compromise the integrity of the connection and the grounding path. Consider the environment in which the tap is made and take steps to protect it from potential hazards such as impact, abrasion, or corrosion. In your specific scenario, you can tie your #6 ground rod wire to the 2/0 grounding electrode conductor, but only if you are using a listed grounding connector or lug. This ensures a proper and safe connection. The tap should be made in a location that is protected from physical damage. One suitable location could be inside the service panel, provided there is sufficient space and the connection can be properly protected. When selecting a grounding connector or lug, ensure it is appropriately sized for both the 2/0 grounding electrode conductor and the #6 ground rod wire. The connector should be made of a material that is compatible with the conductors to prevent corrosion. Install the connector according to the manufacturer's instructions, ensuring a tight and secure connection. When making the tap, avoid damaging the existing 2/0 grounding electrode conductor. Use proper tools and techniques to create a clean and reliable connection. After making the tap, inspect it carefully to ensure that all connections are tight and secure. Visually inspect the connection for any signs of damage or corrosion. It is also good practice to test the grounding system after making the tap to verify its effectiveness. This can be done using a ground resistance meter or other appropriate testing equipment. Ensure that the grounding resistance is within acceptable limits as specified by the National Electrical Code and local regulations. If the grounding resistance is too high, it may indicate a problem with the grounding system, such as a loose connection or a corroded conductor. It is important to address any grounding issues promptly to ensure the safety of the electrical system. Regularly inspect the grounding system, including the tap, to ensure that it remains in good condition. Look for signs of damage, corrosion, or loose connections. If any problems are found, repair or replace the affected components as necessary. Remember that grounding is a critical safety feature of any electrical system. Proper grounding helps to protect people and equipment from electrical shock and fire hazards. By following the requirements of the National Electrical Code and using good electrical practices, you can ensure that the grounding system is effective and reliable. Also, keep in mind that the National Electrical Code is updated regularly. Be sure to consult the latest edition of the code to ensure that you are following the most current requirements. If you are unsure about any aspect of grounding or electrical work, it is always best to consult with a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and in accordance with the National Electrical Code. Additionally, local codes or regulations may have specific requirements regarding grounding. Be sure to check with your local electrical inspector or building department to ensure that you are complying with all applicable codes and regulations. Tapping a grounding electrode conductor is a common practice, but it must be done correctly to ensure safety and code compliance. By following the requirements of the National Electrical Code and using good electrical practices, you can safely and effectively tap a grounding electrode conductor. Now, let's delve deeper into the specifics of grounding electrode conductors and the requirements outlined in NEC Section 250.64e. Grounding electrode conductors play a vital role in providing a low impedance path for fault current to return to the source. This path helps to quickly trip over current protection devices, such as circuit breakers, to prevent electrical shock and fire hazards. The size of the grounding electrode conductor is typically determined by the size of the service entrance conductors. However, the National Electrical Code sets minimum size requirements for grounding electrode conductors based on the type of grounding electrode used. For example, a grounding electrode conductor connected to a ground rod electrode must be at least #6 copper or #4 aluminum. A grounding electrode conductor connected to a concrete encased electrode must be at least #4 copper. The grounding electrode conductor must be connected to the grounding electrode using a listed connector or clamp. The connector or clamp must be made of a material that is compatible with the conductors to prevent corrosion. The grounding electrode conductor must be protected from physical damage. This can be accomplished by running the conductor in conduit or by locating it in a protected area. When tapping a grounding electrode conductor, it is important to maintain the integrity of the grounding path. The tap must be made in a manner that does not reduce the effective grounding path of the grounding electrode conductor. This means that the tap must be made with a listed grounding connector or lug and that the connection must be tight and secure. The tap conductor must be sized appropriately for the equipment or system that it is grounding. The size of the tap conductor must be based on the size of the overcurrent protection device protecting the equipment or system. The tap conductor must be run in a manner that protects it from physical damage. This can be accomplished by running the conductor in conduit or by locating it in a protected area. When making a tap to a grounding electrode conductor, it is important to consider the potential for corrosion. Corrosion can occur when dissimilar metals are in contact with each other in the presence of moisture. To prevent corrosion, use connectors and conductors that are made of compatible materials. For example, use copper connectors with copper conductors and aluminum connectors with aluminum conductors. When making a tap to a grounding electrode conductor that is exposed to the weather, use a weather-resistant connector. A weather-resistant connector is designed to protect the connection from moisture and corrosion. Regularly inspect the grounding system, including the taps, to ensure that it remains in good condition. Look for signs of damage, corrosion, or loose connections. If any problems are found, repair or replace the affected components as necessary. Also, consider the specific requirements of your local electrical code. Local codes may have additional requirements regarding grounding. Be sure to check with your local electrical inspector or building department to ensure that you are complying with all applicable codes and regulations. In summary, tapping a grounding electrode conductor is permitted by the National Electrical Code, but it must be done in accordance with specific requirements. Firstly, the tap must be made with a listed grounding connector or lug. Secondly, the tap must be made in a manner that does not reduce the effective grounding path of the grounding electrode conductor. Thirdly, the tap must be protected from physical damage. Following these requirements will ensure a safe and effective grounding system. Ensure you consult the latest edition of the National Electrical Code and local regulations for the most up-to-date information. When dealing with electrical systems, always prioritize safety. If you are not comfortable working with electricity, consult a qualified electrician. The grounding system is a critical component of electrical safety. Proper installation and maintenance are essential to protecting people and property from electrical hazards. This thorough understanding of NEC Section 250.64e allows for safer and more compliant electrical installations. Electrical codes are in place for very good reason. Make sure you understand the code well, or hire a professional.